Hi, there was some request to do a recording of the quiz solutions. So here it is. So in actually it's just one main question and into many parts. So in the first part, or rather this question, we have a few so-called attributes, and initially they are not arranged in any table, and they just want to find out what are the possible functional dependencies that we can see from there. So these are the four that I have. So evidently the NRSC would be able to define your your A is your name, your home address, and also your work address. I think this should be understandable. The longitude latitude defines your exact location. Longitude latitude should not define your home address, so it is just a generic address for long lat. A is your name. A implies NRSC, which is not correct as well, so you can have people with duplicate names. NRSC and timestamp would define your location. So yes, so at any point of time can only be at one place at one point of time, so this will be unique. This will be able to define your current long lat coordinate. Current location defines your long lat. So yeah. So evidently these are the four that we have. Okay, let's look at the second question. My mouse is not very sensitive. Yeah. So what are the candidate keys? So let's assume that we get the earlier ones correct, or rather the earlier FDs correct. So we then now see that we have A. It's a bit lagging. Oh, what happened? It's a bit lagging. I don't know why. We have A, H, W, C, H, N, L, O. On my left hand, sorry, on my right hand side, what is missing on my right hand side is N, and if I'm not wrong, T as well. Yeah, and if you do the so-called the closure of NT, you'll find that this should be equals to NT, A, H, W, NT implies LO, LO also implies C, and so NT then becomes a candidate key. And if we go on to the example, or rather the question, sorry, you find that NT will be a candidate key. The rest of them actually doesn't cut it. This will not be a candidate key because it is not minimal. N will also not be a candidate key because we need the timestamp. TA not really. TA is timestamp plus home address. Yeah, not really. And LO N and location. This is actually a plausible option as well. Yeah, probably a plausible option as well. I didn't select this though. Let me see why. Yeah, I didn't select this because yeah, I didn't include it as part of the FTs over here. So yeah, but this is a debatable option. Okay, let's look at the next one. Consider these three tables that we split this up to. So when we encounter a problem like this, what we can do is we can try to create you try to find out what are the candidate keys for each individual table. So we have R1, we have R1, R2, R3. So we have N, T, L, O, N, A, H, W, L, O, C. So based on the earlier FTs, we have NT will imply LO for this. NT will be the candidate key, and this will be NAHW, and this will be LO implies C, and C implies LO. So we have these three tables here for this decomposition, and in this decomposition we find that the non-prime keys are we look at for each individual table. So for this table, we find that the non-prime, the candidate key is equal to the left hand side is equal to the candidate key. For this, for the non-prime as well, the left hand side is equals to the candidate key, and there are no non-primes over there. And based on the definition, then this would be under the BCNF normal form. Okay, let's look at this next question. Talking about contact tracing. Let's try to remove. I don't know why my computer is lagging very actually quite badly today. So okay, so in this example, we have 6 hours. So 6 hours, and together we know that the granularity is 1 data point per second. So you have 6 times 60 times 60. There are 10,000 people in the database, so we need to times 10,000, and this will give us 216 million. Okay, this is clear. So the next one will be for table number 2, which is just the number of unique people, which is 10,000. For table number 3, I'm talking about the this will be the location. This is the location long leg pair. So I have stated that the start off very far from one another. So what I'm trying to say over here is that we will have at least in the starting point 10,000 different starting locations, and of course over the period of time of 6 hours they may move about. But I asked about the minimum number of records, so the minimum number of records will be equal to 10,000. Okay, for question number 7, what we have is the following. So one block is 512 bytes, and we have NTLO. NTLO together is about 8 bytes. So I have NTLO which is 8 bytes. So NTLO which is relationship 1. This is 8 bytes, and we know that the one block is 512. So there's 512 bytes. So this is one tuple. The number of tuples, this is one block. In one block will be equals to 512 divided by 8 will be equals to 64. And and based on 64, we know that there are 216 million tuples in relationship 1. So we just need to 216 million divided by 64, and you should get 375,000. I hope. Yeah. So question number 8. So now we are going to a block nested loop join between R1 and R2. So I apologize for this. To be frank, I how to say, when I was preparing the question, I had R2 and R1 in the other side. I don't know why when I copied over, R1 became R2, R2 became R1, and so some of my questions a bit messed up over here. So the numbers, they varied a little bit, but generally fortunately for this question, the screw up wasn't so bad. So yeah, it's actually quite fortunate. So for this, R1 is the outer loop. This is equals to 3. Let's go back to the. This is equals to 337 5,000. Okay, so what we really need to do now is to focus on R2. So if we go up, we find that R2 also takes up 8 bytes per tuple, and we know that R2 has 10,000 tuples, and so the number of blocks will be equals to 10,000 divided by 64, and this will be equals to 157 from what I remember. And the number of and the question states that this is going to be a block nested loop between R1 and R2 with R1 as the outer loop. So it means that for each block of R1, it will go through a block of R2. So this is where the inner loop of the R2 comes in. But at the same time, we also have a sense of the R1 at the outer loop. So this is the cost of the inner loop. This is the cost of the outer loop, and so this will be equals to 3,375,000 plus 3,375,000 times 157, and we should give it the number of 533 million that you see over here. So there's a very small delta, or rather there's a delta between the number, the choice that I gave, because I mix up between my R1 and R2. Okay, so for this last question over here, I don't know why I went to put in the wrong value for the log, and so unfortunately the choices did not appear as the solution. I've already edited the question, as you can see from here. So when we calculate a question like this, we now have the piece of information in the memory. Is 4096. The block size is 512, and so the number of blocks fit memory equals to 4096 divided by 512, which is equals to 8. Yeah, I don't know why in my workings I put this to be 4. So yeah, I really screwed up. I don't know why I put this to be 4 in my workings. So what you want to do right now is you want to find out the number of runs. So of this external merge sort. So we first look at the number of blocks that we have. Number of blocks of R1 is 3,375,000, and the number of runs will be equal to the number of blocks divided by the number of blocks that can fit into memory, which is equals to 8, and we take the upper bound of this, and and this will be the number of runs for the external merge sort, which is the first phase. So as we recall, after we do the number of runs, we need to carry out the merging phase. In the merging phase, we take m-1 as the branching factor, and so in the merging phase, we then need to log this by log 7 of this number. Okay, so this is in the merging phase. In the merging phase, what happens is that we have a read and write for each individual block, and so I will need to multiply 2 times read write for each individual block at the merging phase. I also need to add in a 1 for the initial read and write for all the blocks in my external merge sort. So if I plug in the numbers for BR, which is this number over here, I should be able to get the solution that I just added of which is 54 million. Yeah, so that's it for the mock quiz. As I mentioned in the announcements, I think this mock quiz has a lot of carry forward error. So so in the finals, right, I will not be doing finals like this. So it will be more of single questions, whereby if you get it wrong, then you just move on to the next question, and you won't be penalized. Your subsequent questions will not be penalized because of your whatever earlier errors that were there. Okay, hope this is good. Anyway, all the best for the finals. Stay healthy, stay safe. Okay, cheers.